This is Pallavi Pujar from Biotechnica, and today this is the sixth day of PYQ's discussion series, and definitely you are going to join me today also. And previously you have enjoyed a lot while solving the so many PYQs, and today I have come up with few more PYQs which are a bit difficult and moderate level. Okay, so just let me wait for 1 to 2 minutes, students. Join me faster. You have left with only 10 days for the exam, right? So just okay, Amrita Lakshmi has joined right now. Yes, hello. Hello, Amrita Lakshmi. How are you? How is your preparation? Yeah, hello, Datek. Very good evening. So, students, don't waste your time and join me faster. We'll just finish with the PYQ series for the chemistry, and you have so many questions today also. Okay, so we'll start with the session. Okay, and just let me start with the first question, that is regarding XeF6 and XeO3, XeOF4, XeF4 structures. So the question is like this: match the compounds given in column 1 with hybridization and shapes given in the column 2 and mark the correct options. So they have given you two columns, one is column 1 and column 2, where the A, B, C, D, XeF6, XeO3, XeOF4, XeF4 is being given, and column 2 where the distorted octahedral, square planar, pyramidal and square pyramidal structures you have. Okay, so the first thing, the options whatever you can see, that is option A 1 2 1 3 4 2, and option B where 1 2 4 3 you have, and option C where 4 3 1 2, and option D where 4 1 2 3 you have. So just you have to look at the structures of all the given inorganic compounds and just let me know what option you choose. Okay, already Dedek has answered it as option B. Yeah, hello Priya and Nitin Sharma. Hi, hello. Yeah, so just let me answer it faster, and just you have to know regarding the VSCPR theory so that you can answer me quickly. Yes, students. So shall we look at the answer? So the answer is like this, that is option A. So option A, where the structures they had given regarding XeF6, XeO3 and XeOF4, XeF4 you can see. So the XeO3 you can see here, that is pyramidal structure where the hybridization will be sp3, and coming to the next one is XeOF4, that is square pyramidal structure, and so hybridization will be sp3d2, and coming to the nextly, that is XeF6. Okay, and that is distorted octahedral structure. This is what you have, and apart from that XeF4 is quite important and simple structure where you will be having all side 4 fluorine. Okay, so 4 fluorine you have, and this is what the square planar you have with respect to XeF4. And what is the hybridization? That is sp3d2. All right, so this is what the answer for the given question, and just let us move on further. Okay, so coming to the next question, which one of the following characteristic is associated with adsorption? So the question is based on adsorption. So now you have to pick the one option, that is option A, where they have given the statement as this: delta G is negative and delta H and delta S are positive regarding adsorption process. And option B, where delta G, delta H and delta S all are negative, and delta G, delta H are negative but delta S is positive. And option D, where delta G and delta S are negative but delta H is positive. So which option you choose for the adsorption process? So choose it wisely. Okay, Dathak has already answered it as option B, and Mati Mitra as option B, Nitin Sharma as B, and Priya also as B. All right, so just let us look at the answer. Yes, very good, students. So the answer is B. Okay, why it is B? Why? Because adsorption is a spontaneous process. That's why delta G must be negative, and adsorption is an exothermic process, and that's why delta H must be negative, right? And coming to the last one, where in adsorption entropy decreases, that's why we will always consider it as a negative. So whatever the delta G, delta H and delta S they have given, all must be negative, right? So very good, students. So you have remembered the adsorption process. Coming to the next question, when copper is heated with concentrated HNO3, it produces. So just you have to carry out the reaction between the copper and concentrated HNO3. So what option you choose for this? The option A is like this: copper, that is CuNO3 twice you have and NO2, and B where CuNO3 twice and NO, and option C where the copper nitrate is as it is, but the thing you have along with that NO and NO2, and option D where you have along with your copper nitrate as N2O, right? So which option you choose? So you have to treat with copper and concentrated HNO3. So what answer you choose here? Okay, Deiretic has answered it as option A, and okay. Then Mati Mitra also has answered it as option A, and Vinod has also answered it as option A. Okay, what about remaining students? Yes, very easy, right? So just you have to treat with the HNO3. Okay, let's look at the answer. So the answer is option A. So what you have to do? You have to take copper and consider 4 moles of HNO3 you have. Okay, and that too concentrated HNO3 you have. Okay, so just let me mention it as concentrated, right? So what you are going to form? You are going to form copper nitrate. Okay, that is NO3 twice you have. Along with that, you are going to have your NO2, okay, and H2O, right? So you will be forming copper nitrate along with NO2. So the answer has to be option A. Right. And now coming to the next part of question is the reaction they have given, that is alcohol to ether conversion, and it can be classified as, so what type of reaction it is. So they have given the 4 options. One is Williamson ether synthesis, and option B where alcohol formation, and option C where the dehydration reaction, and option D where Williamson alcohol synthesis you have. So what answer you choose for this question? It is direct question. So you can just by looking at the reaction itself, you can say which functional group you have in your product side, and based on that you can quickly pick the option and just let me know. Yes. Okay, Deiretic has answered it as option A, and Vinod and Mallikarjun Nilkund has answered it as option A. Yes, very good, students. So today you are going to solve more faster than me, right? So just let us look at the answer. Yes. So the answer is option A. It is Williamson's ether synthesis. So in the named reaction itself, you have the functional group as ether. Then option will be what? Option will be A. Now coming to the next question, fifth one, where the number of sigma and pi bond in pent-2-ene-4 wine. So they have given the IUPAC of our organic molecule. So now you have to tell me just by drawing the structure how many sigma and pi bonds are present in a given organic molecule. So just let me know what answer you will give me. So many options are being given. All right. So option A where 10 sigma and 3 pi bonds you have, and option B where you have 8 sigma and 5 pi bonds, and option C where you have 11 sigma and 2 pi, and option D where you have 13 sigma and no pi bonds. So just try to draw the pent-2-ene-4 wine, and accordingly you can collect how many sigma and pi bonds are present in a structure. So just let me know. Quickly answer, students. So first try to draw the structure. Yes. Okay, Vinod has already answered it as option A. Okay, Noble Wolf has answered it as option C. Okay, Daytech has answered it as option A. Yeah, Vinod. Just let us look at the answer. Mati Mitra has answered it as option C, and Priya has answered it as option A, whereas Mallikarjun has answered it option A. Okay, students. So just let us look at the answer K. It is option A, right? So what they had given? They had given pent 2-ene-4 wine. So just how many carbons? Pent matlab in the sense it will be 5 carbons, right? So 5 carbons, and then what you have? One double bond, one triple bond. So this is double bond and this will be triple bond, right? So they have given the position of the double bond. So it will be between 2 and 3 because the lowest number they are considering with respect to C double bonds. Before that, just let me consider 1, 2, 3, 4, 5. So let me number the carbon. And now what you have? Your double bond between 2 and 3. Between 2 and 3, which is the lowest number? 2, right? So you have to take 2 while naming the IUPAC. Now coming to triple bond. So triple bond is between 4 and 5 because they have given the numbering as 4, right? So you have triple bond between 3 and that is 4th and 5th carbon, and now you have on first carbon 3 hydrogens, right? So you have 3 hydrogens, and apart from that on second carbon also you have 1 hydrogen, and here also you have 1 hydrogen, right? So you have 1 hydrogen here, and apart from that here you have 1 hydrogen. So you have to count for the sigma bond and pi bond. So sigma bond 1 2 3 4 5 6 7 8. Okay, so this is what 8 9. Okay, and this is what 10. So 10 sigma bonds you have, along with that 1 2 3. Okay, so these are what pi bonds, these two and this one. So you are correct, your answer is correct, students. So you are answering very quickly and faster than me today. So just let us look at few more questions. Okay, so coming to the sixth question, which one of the following ester get hydrolyzed most easily under alkaline condition? So they have mentioned the condition, alkaline condition. Okay, just let me go back. Okay, so they have mentioned the alkaline condition, so just you have to pick the correct option for ester hydrolysis. So option A, B, C, D, you can look at the structures on the screen. So just let me know the answer, what you will get here. So you must know the reactivity of the ester, whatever they have given with respect to the alkaline condition. Okay, so you know the ester hydrolysis where it is going to give me the carboxylic acid and alcohol, right? So what answer you choose? So quickly students, answer me faster. Yes. So you have to look at the hydrolysis of ester reaction. Just take one by one. So they have given 4 options, okay, 4 structures, and you have to look at the benzene ring substituent. Apart from ester group, whatever you have the substituent on the benzene ring, what exactly it is, whether it will be increasing the electrophilicity of the ester carbonyl carbon, or else it will be decreasing. So which group will decrease and which group will increase, that is the main concept with respect to the reactivity. Okay, so just let me know what answer you choose here. Okay, Priya has answered it as A, and Detek has answered it as option C, where Vinod has answered it as D, and Noble Wolf has answered it as C. Okay, so just let us look at the answer, students. Okay, so the answer is C, right? So why it is C? You have nitro group, right? So you have the simple ester. Okay, so the simple ester, I will mention it as R dash, that is first option, and you have your NO2. Okay, and apart from that, you have your OCH3 group at para position, right? And you have ester apart from this, and you have chlorine, right? So now you must know that whenever you are carrying out any reaction with respect to the ester hydrolysis or any organic reaction mechanism, when you consider with respect to the carbonyl carbon, when you increase the electron deficiency in case of the carbonyl carbon, so that the reaction will be more faster, right? So when you have electron withdrawing group at para position, it is withdrawing all the electron density towards itself. That's why the electron deficiency in case of carbonyl carbon of ester will be increasing. So just let me mention it as RCOO R dash. Okay, so in case of RCOO R dash, whatever the carbonyl carbon you have, so it will increase by reducing the electron density. Okay, so that the nucleophile can come and attack on it, right? So it can come and attack on this electron deficient carbonyl carbon. That's why what we can say, whenever you have electron withdrawing group, it is going to increase the reactivity of ester. Okay, that is what the ester hydrolysis under alkaline condition in the given options, where you have the option C with the electron withdrawing group, it is going more faster. Okay, okay, so coming to the next thing. Yeah, Detek. So you have answered me as NO2 is more reactive than Cl. Yes, obviously, always NO2 group is more reactive than remaining halogens also. Okay, now coming to the next question, the stability of +1 oxidation state among the aluminum, gallium, indium and thallium. So they have mentioned the elements. So now you have to tell me, according to the +1 oxidation state stability, which option you choose. So the option A, B, C, D they have given with respect to their order. So just let me know the options. Okay, Vinod has already answered it as option A, and Mati Mitra has answered it as option D, whereas Datek has answered it as option B. All right. Okay, I'm getting different answers for this question. Okay, so Priya has answered it as option B. Yeah. Okay, just let us look at the answer. Okay, so coming to the answer, it is option D, that is aluminum, gallium, indium and thallium. So with respect to this question, so the easy answer what you can give is inert pair effect, right? So with respect to inert pair effect, whatever the NH2 electrons you have, so these electrons are not involved in the bonding, they kept themselves unshared. That's why, so whenever you go down the group, in the periodic table, the inert pair effect will be operating. That's why the +1 oxidation state will be there with respect to down the group. Okay, so that is what the answer will be, option D for this question. That is, the reason is inert pair effect. Okay, now coming to the 8th question, the question is like this: for a given exothermic reaction, Kp and Kp dash are the equilibrium constants at room temperatures T1 and T2 respectively, and assuming that heat of reaction is constant in temperature range between T1 and T2, and it is readily observed that, so they have given with respect to Kp and Kp dash condition at constant temperature. Okay, so just you have to at constant temperature, it will be the T1 and T2 they have given. Now coming to the options where they have given Kp is less than Kp dash and Kp is equal to Kp dash and Kp is equal to 1 by Kp dash, in the sense it is inversely proportional, and option D where the Kp is greater than Kp dash they have given. So just let me know the answer for this question. Yes, quickly, with respect to the equilibrium constant. Yes. So what answer you can give with respect to the equilibrium constant, okay, at room temperature? So they have mentioned T1 and T2. If T2 is greater than T1, what happens? And T1 is greater than T2, what happens? So you have to know the relationship with respect to the equilibrium constant. So Noble Wolf has answered it as option B. All right. Yes, what about remaining students? What answer you are getting for this question? All right. So just let me know the answer here. The option D is correct, where Kp is greater than Kp dash. So just let me highlight the answer here. Okay. So with respect to this, where the Kp is Kp dash, why it is greater? Because in exothermic condition, okay, in exothermic reactions, on increasing the temperature value, Kp value decreases. And overall, for an exothermic reaction, when the temperature is increased, the equilibrium will shift to the reverse direction. Okay, so it will shift in the reverse direction and the value of the equilibrium constant will decrease. That's why what we can have the condition as Kp is greater than Kp dash. Okay, so this is what the correct option with respect to this question. All right, now coming to the next question. The next question is like this with respect to CFSE, and among the following complexes, the one which shows zero crystal field stabilization energy. So you have to calculate with respect to the CFSE. Better you know the equation what you have to put, and you have to concentrate on the ligand whatever they have given, whether it is weak ligand, strong ligand, okay, or else high spin, low spin, whatever we can say. So the options they have given as A, Fe, H2O6 3 plus, and B where cobalt complex they have given H2O6 2 plus, and again option C where the cobalt complex they have given H2O6 3 plus, and option D where you have the manganese complex manganese H2O6 3 plus. Okay, so what answer you can give for this question? All right, so just let me know. So I have given you one hint that whenever the complex is being given, concentrate on the ligand what they have given. So the ligand they have given everywhere same, water they have given. So now your duty is to just recall whether it is strong ligand or weak ligand. If it is strong ligand, what you have to do in case of the T2G EG whatever you write, and what you have to do if it is strong weak ligand. So just let me know what answer you get for this question. Yes. So Vinod has answered it as option D and Nitin has answered it as option D. All right. Okay, option C. And Mallikarjun Nilgund has answered it as option D and Priya has answered it as option D. Okay. So just let us look at the answer, that is option A. So where you have got the 0 CFSE for the iron complex. So iron Fe you have. So what configuration you can write? You can write it as D6S2, right? So how many electrons you have? Valence electrons, it is 8, right? So Fe is under 3 plus oxidation state. Okay, so just let me write it separately so that you will not confuse it. Okay, so coming back to the Fe 3 plus oxidation state electron configuration. So what you have? 8 electrons you have. So 8 minus 3 you have to do, right? So 8 minus 3 will be 5. So how many electrons you have? 5 electrons you have right now. So now it is octahedral complex, right? So you have to show T2G down and EG upside. So now you have 5 electrons, 1, 2, 3, 4, 5. So here I have not paired up the electrons. Why I have not paired up the electrons? Because water is a weak ligand. If it is weak ligand, there will be no pairing of the electron. That's why I'm keeping it constant. Okay, so just I'm keeping as it is. So you have now T2G, okay, and EG, right? So now what you have to do? You have to calculate your CFSE. Okay, so just calculate the CFSE. So what you will get here? So just let me show you by erasing few points on the screen which are visible for you. I hope you have got the point, right? So coming to the EG and T2G level, so we know that this will be 0.6 delta naught, right? And this downward will be 0.4 delta naught, which is negative. So in order to calculate the CFSE value, what you have to do? You have to consider the energy. So this whatever you have, the gap, that also you have to consider. Along with that, you have to consider the number of electrons present in the T2G and EG level. So now in T2G level, how many electrons you have? You have 3 electrons, right? So it will be 3 into minus 0.4, right? So nextly, plus charge you have to put, then what you have, plus you have to put, and then you have 2 electrons, and this I will write it as 0.6, and overall it will be delta naught, right? So 3 into minus 0.4, right? So it will be minus 1.2, plus again it is 1.2, 1.2, both are getting cancelled each other, and you have got the answer as 0, right? So this is what you have got the CFSE calculation for the water complex of IE, right? So the IE complex whatever you have got, that is iron complex whatever you have got, so you have got the value as 0, right? So like this way you have to calculate for the remaining complexes also, you will not get 0. And for this question the answer will be option A. All right, now we'll go on further. So next question is, of the following, which product is formed when cyclohexanone undergoes aldol condensation followed by heating? So they have mentioned two things. Okay, so we know that aldol condensation product what you will get, right? So we know that, but apart from that they have mentioned that it is undergoing aldol condensation and followed by heating. Okay, they have not stopped till aldol condensation. Further they are heating the compound and you are getting some X product. Okay, so now you have to tell me that X product, what is this, right? So the options A, B, C, D, the structures you can look. Okay, just let me know the answer what you will get here. All right. Okay, so what answer you will get for this question? So I know better, you know better regarding the aldol condensation, how you can do it. Just consider any base, abstract the proton from the alpha position. So you have to first draw the cyclohexanone. Just draw the alpha proton by using base, okay? And then the carbon ion will be generated, right? It is going to attack on the next cyclohexanone molecule, and side by side you will get the adduct, right? So where you are going to remove water molecule, right, just upon heating, and you will get your final product as X. So just let me know the structure, what you will get for this question, right? So just let me know what answer you will get for this question. Yes. So whatever the steps I have given with respect to aldol condensation, so first you have to follow with respect to the base. Okay, so just consider base, then accordingly you will get your X product. So Vinod has answered it as option B. All right. What about remaining students? Are you getting me or not? If you are not getting, you can ping me in the chat box so that I can clear it here only. So don't take your head into your head. Don't take your problems into your head. Okay, that will be very critical for you to answer so many questions. So whatever the doubts you have to clear at instant. All right. So Devatak has answered it as option C, and Priya has answered B, whereas Matimitra has answered it as option C, and Mallikarjun Nilkund has answered it as option C. All right. So just let us look at the reaction directly, and then we can get the answer. Okay. So coming to the answer point. Okay. So first, what you have your cyclohexanone, right? So you have to treat in the presence of base. So just let me consider it as any base. Okay. So now what you have to do in the presence of base, the proton from the alpha position will be grabbed. So just I am grabbing this proton by using base. So what you will get here, you will get this structure. Okay. So just let me write it properly. Okay, so you have your cyclohexanone along with charge because you have grabbed one proton, right? So now what you have to do, you have to consider another mole of cyclohexanone. Okay, so cyclohexanone you have to consider, and you have your carbanion which is ready, and it will attack on the C double bond O. Just let me show with different ink here. All right, so this will be what it is attacking on the carbonyl carbon. Okay, and what you will get here, you have your cyclohexanone as it is. Along with that, the charge will be shifting towards the oxygen, and here you have your cyclohexanone as it is, right? So you have your oxygen with negative charge. Now by using water where the proton will be released and this oxygen will grab the proton. Okay, so you will be getting the structure like this is C double bond O. Okay, and what else you have, you have the connectivity between the two rings. Okay, and you have OH here. All right, so next what you can do, just you have to notice one thing here. So this carbon is carrying one proton, right? So just upon heating, this water molecule will be eliminated. So just you have to remove the water molecule, that's it. So next what you have to do, so next you have to get your final product, right? So this will be like how, by removing water molecule, this proton will be giving electron to this bond, and it is forming C double bond C here, right? And what you can have your simultaneous side ring, right? So what answer you have got, you have got the answer as option B, right? So this is what the answer you have got, right? Now coming to the next question. Okay, now coming to the next question, it is because of inability of ns2 electrons of the valence shell to participate in bonding. So they have given four options, okay, with respect to the tin and lead, and the oxidation state also they have mentioned, that is Sn2 plus and Pb4 plus. Okay, so you have to know that regarding their oxidation state, whether it is acting as oxidizing agent or as reducing agent. Okay, so with respect to this, you have to apply the inert pair effect concept also. Okay, so just let me know the answer what you will get. So the option A, they have mentioned it as Sn2 plus is reducing while Pb4 plus is oxidizing, and option B where the tin plus, that is Sn plus 2 is oxidizing while Pb4 plus is reducing, and C where Sn2 plus and Pb2 plus both are oxidizing and reducing, and Sn4 plus is reducing while Pb4 plus is oxidizing. So what answer you will get with respect to this? So just let me know the answer, students, what you will get with respect to this question. This is quite easy. So as in case of the previous question where we were solving, so there I had told regarding the inert pair effect, right? And similarly here also down the group, so you have to apply the inert pair effect concept. So just let me know what oxidation state will be more stable for the lead and tin. Okay, so with respect to that, you can tell me whether it is acting as oxidizing or reducing agent. Okay, so just let me know what answer you will get for this question. So just you have to apply the inert pair concept. Okay, Priya has answered it as option D and Noble Wolf has answered it as option B. All right. Mati Mitra has answered it as option B. Okay. What about remaining students? Are you getting the point? Okay, Mallikarjun has answered it as option B. Okay, so you all have answered it as option B. Okay, let's look at the answer. So the answer is option A. It is the SN2 plus A is reducing, okay, and PB4 plus is oxidizing. So as we go down the group, okay, so lead will be at last, right? So lead, and here it will be tin. So we know that whenever we consider with respect to the oxidizing and reducing nature, the lead will be always trying to stay in +2 oxidation state. Okay, so it consider itself that the stability of the lead will be always depending upon its +2 oxidation state, right? So +2 oxidation state in the sense, in the options whatever they have given, the option A where the PV4 plus is oxidizing, in the sense it is ready to lose, right? So here it is what, it is gaining the electron, right? It is gaining the electron and it is converted to +2, right? So PB4 plus 2, PB2 plus you have, right? Now coming to the tin, so tin will be always try to be in the +4 oxidation state, +4 oxidation state. That's why we have the tin whatever SnCl2, SnCl4, right? So many compounds you have, so it will always try to stay in +4 oxidation state. So +2 to +4 oxidation state, you can convert it easily. So for tin, it will try to be in always +4 oxidation state and it will act as reducing agent, right? So it will undergo self oxidation and reduces others, but lead will be like it will be reverse case of the reduction, where it will be acting as the oxidizing agent, in the sense it will be oxidizing others but self reduction, right? So that is what the option A has to be correct here. All right. Now coming to the next question, what else you have? Okay. So the next question is like this: the correct order of nitrogen compounds in its decreasing order of oxidation states is. So they have mentioned few compounds. So now you have to tell me with respect to the nitrogen oxidation state in every molecule with respect to their decreasing order. So just calculate the oxidation state of nitrogen in every molecule and let me know what you will get for this question. Okay, so what answer you will get for this question? So just let me know. Yes. So each and every molecule with respect to their charge contribution, just add it. How many for oxygen, chlorine, hydrogen, and calculate. This is direct question, right? So Vinod has already answered it as option A. Okay. What about remaining students? What answer you will get for this question? Yes. So try to solve by applying the oxidation state method. So where you have to consider with respect to the nitrogen as X, consider it as X, and the remaining whatever the elements you have, hydrogen, oxygen or chlorine you have, consider with respect to their contribution, right? So how many oxidation state you consider with respect to that, and let me know the answer what you will get for HNO3, NH4Cl, NO, N2. So they have given so many options. Okay, so many options you have and so many compounds you have, right? So just let me know what you will get with respect to each and every molecule. So Daytech has answered it as 12C. Okay, option C. All right. Now Obel Wolf has answered it as option C. Okay, so just let us look at the answer. It is option C. So first it has to be HNO3, okay, and then NO, N2, NH4Cl. So according to this HNO3, okay, so it has to be capital. Okay, so HNO3. So just nitrogen you have to consider it as X. So just let me consider it as X. So hydrogen will be contributing 1, right? So how many you have? Only 1 you have. So just consider it as 1 here. Okay, so just let me write it properly. So by considering that 1 into 1 you have, right? Plus oxygen will be how many? It will be -2, and how many you have? 3, right? So X will be minus. So this will be minus 2 into 3 will be -6 plus 1, right? So -5 you will get. that will be overall equal to 0, then X will be equal to 5, right? So you have got this answer for HNO3. So in HNO3, nitrogen is in +5 oxidation state. Coming to NO, where you have to consider nitrogen as X and oxygen, it will be -2. So you have only one oxygen. So X will be equal to +2, right? So you have got the answer as +2. Now coming to N2, so for N2, how you can calculate? Just let me erase all cases, okay? So coming to this, where N2, so N2, nitrogen will be considered as X, right? So how many nitrogen you have? 2X, that must be equal to 0. Apart from that, you don't have any element, right? So X will be equal to 0, right? So that is what you have got the answer. In case of NH4Cl, so just consider nitrogen as X. Now hydrogen will be 4, right? So 1 electron. And with respect to chlorine, it will be -1, right? So you have only one. So this will be equal to 0. So X will be X plus 4, okay? -1 is equal to 0. So X plus 3 is equal to 0, in the sense X must be equal to -3, right? So this is what the answer you have got overall with respect to their corresponding oxidation state in the given molecule. All right. So the answer is correct here. Now coming to the next question is, which of the following oxide is most acidic in nature? So they have given few oxides, metal oxides. So you have to know, you have to tell me the option. So which one will be correct? So the option A, you have the barium oxide. Option B, whereas it is beryllium oxide. Option C, where it is magnesium oxide, and option D is calcium oxide. So what answer you will choose for this question? Okay, so just let me know what answer you will get for this. Okay, Vinod was answering something oxidation state for I3. What is this? I didn't get that last keyword, whatever you have put. Okay, now Matimitra has answered for this option B, this question. All right. Okay, Mallikarjun Nilgund has answered it as option C. Okay, Datek has answered it as B. Okay, so now let's see with respect to the answer. So the answer is option B, beryllium oxide. So with respect to this, again, what you have to consider, so with respect to this, so as you go down the group in the periodic table, and especially they have given you alkaline earth metal oxides, right? So whenever we consider with respect to the basic and acidic nature of any element, I mean metal oxides, it will be depending on either electropositivity or the electronegativity, right? So now they have asked regarding the acidic nature. So the acidic nature, in the sense, you have to concentrate on the central metal atom electronegativity. We know that as you go down the group, the electronegativity will be decreasing, right? Suppose you take in case of the halogens, okay? So in case of halogens, so fluorine will be most electronegative, and downward when you go, okay, with respect to iodine, the electronegativity is less, so that you can remember the halogens more faster compared to remaining all elements. So that I have given the halogens as an example. Okay, right now coming back to the metal oxides in case of alkaline earth metals. Okay, so in case of this, what you have metal oxides. So with respect to electronegativity, as you go down the group, the electronegativity is decreasing, right? So electronegativity is decreasing, in the sense there the basic character will be more, right? So basic character is more downward, in the sense upper side will be acidic character will be dominating, right? That's why what we can say, beryllium oxide compared to barium, magnesium, okay, and calcium. Okay, barium, magnesium, and calcium, so it will be more acidic compared to these all three elements. Okay, so these all will be coming downward, whereas beryllium is upside, right? So that what you can take one hint, that whenever you go down the group, the electronegativity is decreasing, simultaneously the basic character of all metal oxides increases, and that's why in the beginning, whatever the upper elements you have with respect to them, where their acidic character will be more, right? So this is what the hint you can give with respect to this question. Okay, I guess the doubt is clear and the concept is clear with respect to this question. And now let us move on. Okay, the 14th question. The under isothermal condition, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure of 2 bar, and the work done by the gas is. So they are asking regarding the work done, and they have mentioned also that is 1 liter bar is equal to 100 joule. So you have to convert the whatever the answer you will get, you have to multiply with 100 joule and you will get your answer in joule. So just let me know what answer you will get with respect to this question. That is A minus 30, B 5, and C 25, and D 30 they have mentioned. So just let me know what answer you will get for this question. So you have to apply the formula W is equal to so and so. So one equation is there. So just try to apply that equation, that is work done equation, and let me know what answer you will get. Easiest question, right? So they have mentioned the pressure, right? The external pressure of 2 bar, and you have to consider the volume range V2 minus V1, and you have to tell me the answer. Okay, Dirtak has answered it as option A and Vinod has answered it as option A. Okay, just let us look at the answer. Yes, so the answer is option A. Very good, students, both of you. And now coming to the solution part, you have your equation, that is W is equal to minus P external, that is pressure at external, okay, and that will be delta V at last. And minus P EXT, they have already mentioned it as minus 2 bar, right? So 2 bar they have already mentioned, so minus is already present in the equation part, right? And now delta V, the volume also they have mentioned it is 0.25 and 0.1, right? So you are considering with respect to V2 minus V1. So if you solve this, you will get 0.15, and that 0.15 into 2, you will get 0.30 liter bar, right? So now you have to convert your answer into joule. They have given the answer in joule, right? So now 0.3 into 100 joule, if you do, you will get minus 30 joule as the answer. All right. So this is what the answer with respect to this question. Okay. Yeah. So now Priya has answered it as option A, and Nitin has also answered it as option A, and Noble Wolf has also answered it as 30J. Right. Yes. Very good. Now coming to the next question. Okay, the calculated spin only magnetic moment of Cr2 plus. So you have to calculate the magnetic moment with respect to chromium. Okay, and they have given the 4 options, where the option A is 3.87 Bohr magneton and 4.90, that is option B, and option C where it is 5.92 Bohr magneton, and option D where it is 2.84 Bohr magneton. So just let me know what answer you will get for this question. Yes. So you have to use the magnetic formula, magnetic moment formula, that is square root of n into n plus 2. The equation better you know. So now your duty is to calculate the number of electrons with respect to chromium, that is in plus 2 oxidation state. So first you have to do this. Okay, so now you have to consider the electronic configuration of chromium. All right, so next step what you have to do, you have to consider its electronic configuration in Cr2 plus, that is plus 2 oxidation state. Now what you have to do, you have to calculate so and so n value you will get, right? So now at last the square root of x will be options. So whatever the options they have given, that may be 3.87, 5.92, 4.90, or else 2.84 also. So Dirtak has answered it as 4.8. Okay, Mallikarjun has answered it as option B. Dirtak has answered all right. Noble Wolf, Nitin Sharma, okay, both have answered it as option B. All right, and Priya also has answered it as option B. Okay, so just let us look at the answer. Okay, so Dirtak has taken in brief with respect to the equation S. So the answer is option B, that is 4.90 Bohr magneton. Okay, so how you have got that? So for this you have your Cr, right? So Cr in its electronic configuration, if you consider, it will be D5 4s1, right? So they have mentioned it is under plus 2 oxidation state. So plus 2 oxidation state where you have to remove 2 electrons. So just remove 2 electrons, so it will be 4, right? So 4 you have got overall total electron. So now your n value will be equal to 4. Now you have to put this in the equation, that is n into n plus 2, right? So this will be what? Square root of 4 into 4 plus 2, right? So what you will get? You will get square root of 24. So square root of 24 will be 4.90. So this is what you have got overall the answer, that is option B. Okay, so very good students. So all of you have answered it as option B. I'm very happy for you. Today you are solving more and more questions and very quickly, and definitely you are going to achieve your dream and whatever you have come up with in your head, right? So like that you have to answer a few more questions along with me. So you have to be there with me till last moment and we'll finish it. Okay, that too in positive way. So coming to the sixth question, which of the following oxo acid of sulfur has oxygen oxygen linkage? So now you have to consider with respect to what? Oxygen oxygen linkage. So they have given four options. Okay, H2SO3, that is sulfurous acid, sulfuric acid, and peroxosulfuric acid, and pyrosulfuric acid. Okay, so what answer you will get for this question? Yes, Vinod has answered it as option C, and Amers has answered it as option C, whereas Noble Wolf has answered it as option C, and Matimitra has answered it as option C, and Daretek has answered it as option C. All right, and Mallikarjun, Nitin Sharma, both of you have answered it as option C. Okay, so now coming to this, just let us look at the solution. Okay, so the solution part, option C, right? So now just let me show you one thing here. When they have given any option, so what they have asked you, they have asked regarding oxygen oxygen linkage. Now coming to the first option, they have given it as sulfurous acid, so it will be H2SO3, right? So H2SO3, where you have one sulfur and you have one oxygen. Just you have to concentrate on the hydrogen and oxygen part. So we know that in all sulfuric acids, whatever the acids you have there, it will be present as OH, right? So just try to finish it first. So in H2SO3, I will mention it as OH here, right? And double bond O, double bond O. Okay, and it will be like how it will be, it will be HSO3. Okay, so it will be what? H2SO3 you have, right? So there will be only one bond and one hydrogen. Okay, this will be H2SO3. Just let me show it properly so that it will be clear for you instead of confusing. Okay, so it will be OH. So H2SO3, where you have two OH and one oxygen. Now coming to H2SO4. Okay, so coming to the H2SO4, so you can show it like this. So you can show it like this. Just let me choose different thing. Sulfur and again OH, right? And S double bond O, right? So this is what? H2SO4. Now coming to the next, where H2S2O8, you can show like this. So you have two sulfurs. So just let me show it like this. Two sulfurs you have. Apart from that, two hydrogen and 8 oxygens you have, right? So now I will show, whenever you have hydrogen, it will be present along with the oxygen, right? So I have shown two hydrogens. Okay, apart from that you have 8 oxygen. So between among 18 I have shown two, so remaining I will show like this: oxygen, 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 right? So total 6 oxygen you have. Apart from that, two more are left, so I can show it like this, right? So I can show it like this and now satisfy their valencies, right? So this is what the structure you have got for H2S2O8. So you have your oxygen oxygen linkage in case of H2S2O8. So this is what the option C is correct. If you try for the H2S2O7, it will be like this. So just let me show you here only. So there will be one oxygen. Okay, so there will be one oxygen with respect to sulfur sulfur linkage. So that will be equal to 7 oxygen and 2 hydrogens and 2 sulfur. So this is what H2S2O7 structures. And they have asked you regarding O2 linkage, and you have answered me it very well, right? So this is what the answer. Now coming to the next question, students, that is 17th one. A tertiary butyl carbocation is more stable than a secondary butyl carbocation because of which of the following? So they have given few effects. Okay, minus R effect of methyl group, or plus R effect of methyl group, or minus R effect of methyl group, and hyperconjugation. So whatever they have given the options, among those you have to choose one answer, and it has to be dominating. So we know that we have so many things: inductive effect, mesomeric effect, resonance effect, but among those all effects, one effect is dominating right? One effect is more dominating with respect to the carbocation stability, right? So now just let me know what answer you will get with respect to the tertiary butyl carbocation. So just let me know what answer you will get. Okay, data has answered it as option D, that is hyperconjugation, and Vinod has answered it as option B, whereas Mati Mitra has answered it as option D. All right, and now coming to the next remaining students. Yes, please. Yes. Okay, Mallikarjun has answered it as option D, and Deratek has answered it as option B again. Okay, all right. So you have so many confusions. So the main confusion thing here is between so many effects, right? So the answer has to be option D, because when you consider the hyperconjugation effect, the hyperconjugation will be more dominating with respect to the stabilization of the carbocation. So when you consider the hyperconjugation effect, it will be mainly we can call it as no bond resonance also, right? So no bond resonance, where with respect to their delocalization of where the sigma bond to pi bond conversion we have, right? So this mainly stabilizing the carbocation, and that's why the option D has to be correct here. Okay, so the tertiary carbocation are stable due to inductive effect, that is plus I effective of alkyl group, and hyperconjugation also, and hyperconjugation is more dominating over remaining all effects. Okay, now coming to the next question part is the elimination reaction of 2-bromopentane to form pent-2-ene is. So they have given the conversion of 2-bromopentane to pent-2-ene. Now your job is to just look at A, B, C, D, whatever they have given, beta elimination and Z-save rule, dehydrohalogenation and dehydration reaction, right? So you have to tell me whatever the statement they have given, whether the reaction conversion is following or not. So option A, where ABC, ACD, BCD, ABD. So many options they have given. Just let me know what answer you will get for this question. Yes, please. So you have to, if you want to answer this, if you want to answer this question, now you have to convert the 2-bromopentane to pent-2-ene, so that you can answer me very well. So you can either apply the beta elimination, Z-save rule, or dehydrogenation, that is dehydrohalogenation and dehydration reaction. Okay, so just let me know what answer you will get. All right, Priya has answered it as option B, and Noble Wolf has answered it as option C, whereas Mallikarjun has answered it as option D, and Diratek has answered it as option C, B, C, D. All right, so the answer is option A, where it is following beta elimination reaction, Z-save rule, and dehydrohalogenation reaction. Coming to this, in case of the conversion, just let me show here only. Okay, so with respect to 2-bromopentane, so you have 1, 2, 3, 4, 5, right? So 2-bromopentane you have, and you are converting. Okay, so simultaneously there will be hydrogens also. Okay, so just I am showing it here directly, hydrogen, and here CH3. So you are converting it into pent-2-ene, right? So there will be CH3. So just let me show it properly. Okay, so we have carbon, okay, and here you have carbon, okay. Between 2 and 3 there will be one double bond, so this will be C double bond C and CH3, okay, and here there will be CH, again CH2, CH3, right? So this is what you have with respect to the conversion. So the first thing what you have to notice is the beta elimination reaction. So why it is beta elimination reaction? You are going to remove the hydrogen also, okay, and where the halogen is also going out. So this is overall where you can have the HBr removal. So you can remove hydrogen along with the bromine, right? And now coming to the Z-save rule. So according to Z-save rule, whatever the C double bonds you are going to form, it will be like this with respect to this C double bonds. If you want to draw the structure, so it will be like highly substituted alkene you are going to form, right? That's why the option means the statements A, B, C all are following, and that's why option A has to be correct answer for this question. Okay, now coming to the next question, the decreasing order of stability of O2, O2 minus, O2 plus and O2 minus. So they have given you the O2 molecules, and just let me know what answer you will get for this question. All right, so what answer you will get for this question, just let me know. So here you have to calculate the bond order with respect to O2, O2 plus, O2 minus, O2, okay, O2 2 minus, and then you will get the answer. So if you want to answer this question, just let me give you one hint. So we know that O2 will be having 16 electrons, right? So 16 electrons it has in the sense. Now you have to add up and just reduce some electrons, and accordingly you are going to get your answer. So Mallikarjun has answered it as option D, Vinod as option C, and Noble Wolf as option C. All right. So just let us look at the answer. So the answer is option C. So the answer C is O2 plus, O2 and O2 minus. So when you have O2, and just let me choose the ink here. Okay. So O2, O2 plus, okay, and O2 minus and O2 2 minus. Okay, so O2 plus in the sense you are going to reduce one electron, so it will be 15, right? And O2 minus you are going to add one electron, right? So this will be 17. O2 2 minus where you are going to add two electrons, so 16, 17, 18. So where you have O2 16, right? So you are going to add 18. So like that, if you calculate overall, so you are going to get the order as O2 plus first, and then O2, then O2 minus, then O2 2 minus. Okay, so that you can get the answer as option C for this question. Okay, so now the remaining question again we'll solve it in upcoming session, and before that we have come up with so many videos in Biotechnica channel, and especially for you all guys, that is for NEET aspirants. Please watch those all videos in Biotechnica channel, and definitely it will be beneficial for you. Just get benefit from them, and definitely we will be uploading few more videos regarding the NEET examination also. Until that, thank you, bye bye.